Good day to all of you. Thanks for joining us from all different parts of the country, and welcome. My name is Tom Tansy. I'm the chairman of the SunSpec Alliance, and I'll be your host today. We look forward to spending the next 60 minutes with you as we discuss the opportunities available to find good jobs that are distributed across the country in the distributed energy industry. So during this session, you will learn about jobs that are available in the distributed energy resources industry, and these jobs are available to people of all skill levels and backgrounds. The pay associated with these jobs is impressive, so you'll learn about that, different opportunities where you can enter the industry, and finally what you need to do to prepare for meeting the challenge of getting into the distributed energy industry and taking advantage of it. Before we start, I would like to just make a brief introduction to the SunSpec Alliance. We are the manager of the Cyberguardians program, the program that you're going to learn about today. And we are a trade alliance. Our mission is to develop information standards for the distributed energy industry. We're quite proud of our accomplishments over the past 11 years now, including being included in the IEEE 1547 standard, which is the law of the land for distributed energy. So there you'll find our SunSpec Modbus standard reference. We also work extensively in the other areas of DER communication protocols like IEEE 2030.5 and to a lesser extent in DNP3. But those three protocols are important aspects of this new DER environment. We have outstanding board members and representation from our 120 member companies, and by virtue of publishing all of our standards, all of our information on an open royalty-free basis, we have adoption and influence through about 1,000 member companies, all of which you'll have opportunity to meet by participating in this program. That's my smiling face on the left. I'm Tom Tansy. And I'll be joined today by David Erhart. David is the Vice President of Engineering for a company called STEM. They're a global leader in energy storage and have broadened their portfolio to encompass all aspects of distributed energy resources. So you'll hear from David towards the end of the presentation. So I'll be going through some introductory remarks, and then we'll have a conversation with David about what it's like to recruit into his industry and what the opportunities are for you there. This is an open mic session, and so I have muted everyone at the moment. When we get to the end, I will unmute you, and so that can be a bit of a cacophony. So if you have background noise, please mute yourself. Otherwise, I'll have to go back to muting everyone. But we wanted to make it open mic so everybody gets the chance to speak and ask their questions. You can ask your questions in a couple different ways. One is certainly to put them in the chat box. We'll address them in due course. And then the final 1/3 of the meeting is really focusing on interaction and addressing any of the questions you may have about any aspect, whether it has to do with the material, the technical material that we're discussing, the jobs offered, what the training's like, etc. Finally, the slides will be distributed. So if you have registered, you will get the slides. So no worries about that. Today's agenda will first of all cover the landscape for distributed energy resource industry employment. And this is quite interesting because it's not only nationwide, but actually it's a global opportunity. We'll be focusing in on the U.S. opportunity, but please do keep in mind that there's jobs everywhere, and the employers that we're featuring and that are likely to employ you have operations in all different parts of the world because it is a growing business. Second on the agenda is, why do we need Cyberguardians? What's the whole purpose, and what's the big deal about Cyberguardians, both the education and the initiative? Third in the lineup, we want to answer the question, what's in it for you? So as a veteran, student, and a job seeker, why should you care about this initiative? What are the courses of study that are available to you? What are the jobs available to you? how do you qualify for a scholarship, and how do you get connected with those employers. So this really is the heart of the story for today. And then finally, we'll get the employer perspective. Here's where David will come in, and he will hopefully describe to us why he's interested in the initiative, why his company's interested in the initiative, why he got involved, and what he's looking for in employees that he can bring into his growing organization. Okay, let's dive into it. The U.S. power grid is changing very rapidly. It's grown from a niche business available in a few sunny states, and it's now available across the country and, as I mentioned, across the world. The characteristics of this U.S. power grid is, first of all, it's a lot smarter than it used to be. Two-way flow of energy is taking place all over the place. We see the electrification of major elements of our society coming into play, putting even greater demands on the grid, and therefore it's got to be smarter. It's also highly integrated. Here we're highlighting the case where we have solar energy next to biodigesters and other forms of renewable energy that are being used to power the local farm in this case. And this is becoming quite common. When we also say it's integrated, here we show it being integrated in a farm, but of course it's integrated into buildings, into critical infrastructure and the like. Each of these areas has unique characteristics that need to be understood and offer unique opportunities for employees coming into the sector in your local area. Next up, the grid needs to be resilient. Long gone are the days now where we can rely on central generating plants, and also long gone are the days when we can rely on the farmer's almanac to tell us what the weather's going to be like, because it's the weather's changing. It's creating changing conditions on the ground that are having an effect on our power grid. So by its very nature, it has to be more resilient if it's going to serve the local population and the uses that are required for it. So that requires a different way of thinking. It's a different architecture on the grid overall as it moves from centralized to distributed. Again, needing those special skills that hopefully we'll find within this group. Distributed energy is also local. It's an issue of local concern to the governments, to the cities, but also of local concern to the businesses and institutions that rely on it. It's long gone are the days where you can rely on some central authority. It's about autonomy these days, and supplying your own energy is part of the mix. And so, of importance here, it's an opportunity to engage in the community, to build stronger, more resilient communities by getting involved in the initiatives that are of import to you. You know, and I've highlighted these various pictures that are literally taken from California, from Iowa, from New York, and now we have Florida. So you have distributed energy in each case. It looks different, characteristics are different, and of course, serving a local population and business uses. Finally, the power grid is becoming more communicative. In the year 2018, this IEEE 1547 standard that I mentioned was modified, and in that modification, which was made to enable and allow for far more distributed energy to come on to the grid, it added a very important feature, and it said to the industry that all distributed energy must communicate. This is a brand new requirement because the standard previously talked about electrical function only, and it now has incorporated communication. So this brings about all sorts of new opportunities to be more reactive, to be more resilient, and to be more on the spot. But it also brings about the need for increased levels of protection and coordination because it's now become a very sophisticated system. Hence the need for cybersecurity in this arena. So it's a game changer for the energy industry to bring in communication capability, but also exciting because it allows us to put more and more of this distributed energy onto the grid, providing a better user experience and a more resilient user experience for all that rely on it. Of critical import, in 2019, 250,000 jobs in the United States alone came about directly from, in this case, solar industry. So if you add in wind, the fraction goes much higher. Now, it's sad to say, like all aspects of our society, COVID has taken its toll. So the amount of jobs went down commensurate with construction being shut down. That's not going to be forever. And the economics, on the other hand, of distributed energy are doing nothing but improving. So we expect a very strong rebound in the jobs needs, not only in this country, but in other countries. And as a result, we're going to have a huge vacuum for jobs. Now, those jobs will be different because of all the aspects I've just highlighted here, indicates that the worker of the future needs to have different skills than the worker of the past. So finally, it's really exciting for me to think that what we're doing here in the United States can really be the template for the rest of the world. The United States, in large part, although we were a laggard in terms of initial adoption, in terms of technology development, we're absolutely driving the equation for the rest of the world. So what we do here, I think, in fact, can be replicated elsewhere. So where are the jobs? Many of the jobs are exactly where you'd expect. You know, you see solar panels on rooftops and out in the field. Yes, those things have to get installed and deployed. So roughly 2/3 of the jobs are associated with that discipline. And these are construction jobs, and these are good jobs, but they're not the only jobs in the field. What's of interest to me personally is to look at all of the other factors or sectors that make up the remaining 1/3, because it's not exactly what you'd expect, but it also is an indicator of where the better pay can be found. And manufacturing, operations, and maintenance are a growing field, and this whole concept of all others. Taken together, it's about 1/4 of all jobs, and what you'll find is that the pay that can be found there is indeed superior. But it requires different types of skills than what the solar industry has previously thought of as being important. Another aspect of these jobs is that, as you'll see here, 2/3 will be brand new. What this shows is an industry that's going through very rapid growth, almost exponential growth on a worldwide basis. This creates a huge strain on the labor pool, and it means that workers that are inside these companies are getting trained as quickly as they can, but still that's not enough. And so the industry needs to look to the outside world and to bring in literally large armies of new people to come in and take on these new positions. Now, you have to be trained, you have to be prepared, otherwise you're not going to be successful, but these opportunities exist, and they exist in every part of the country. And one of the data points I'll point out is in my old stomping grounds in Montana actually hit the leaderboards in 2020 for the first time in terms of solar deployments. And I never would have thought that, being far away from population center as it is. But in fact, that just goes to show you about how dispersed and how prevalent this type of technology is across the country. So which jobs are the most difficult to fill? Not surprising, as you'll see there in items number 4 and 5, installation workers, 3 and 4, electrician, construction workers, and installation workers comprise about 44% of the hard to fill jobs. Well, that's because of the huge construction pipeline. So this is strictly a numbers game, and that's my read there, is that as you saw, about 2/3 of the jobs are there. So of course, those are going to be hard to fill, especially when you're talking about bringing in new workers. What is more surprising to me is to see how difficult sales, marketing, customer service jobs are to fill. About 30% of the total, more than 30% of the total. These are good paying jobs as well. Now, for a new entrant into the field, the next level down, the management, directors, supervisors, vice presidents, perhaps you'll qualify for these, but probably for many people that are getting into the field, you come in a lower range. So then, where it gets, I think, really interesting, and will be what we'll focus on here as well, is all of these other sort of long tail types of jobs: engineers and scientists, technicians, mechanical support, operations and business development. Here you have more than a 1/3 of the jobs that are hard to fill those categories, and designers, finance positions, administrative support, etc. So these are a lot of traditional industry disciplines that are being applied in greater measure to distributed energy, and which is good, because that means a lot of the training that you've already previously received is totally apropos for this field. However, you need the specialty skills that come along with the energy industry. You need to understand the terms of art. You need to understand the basic construction of the business itself. And so that's where this program can help out. So this begs the question: you got a hard to find job, so what do they pay? Well, as you'll see, the problem isn't the pay. These types of jobs have higher than average wages, I think, on a national basis. And even down to the vocational side, where the construction wages and technician wages, I think, are in general higher than many other competing similarly situated vocational fields. But now, going back to the top and the technical range, so in this gets back to this point about, again, why veterans. Veterans are coming out with diverse skills, and so if you are on the track to become an engineer or a technician, if you know something about cybersecurity, you can expect, I think, pretty high entry-level jobs, and with the ability to grow pretty rapidly into higher and higher wage rates. Now, your mileage is going to vary, because what you get paid in Iowa or in South Dakota may or may not meet what you'd see in California or New York. Although the flip side is maybe it will, as we've seen with some of these boom areas where you need to import your labor and your talent. There are premiums paid there as well. Big sector of the business is in this operational and professional sector. This is reflective of the need for more business people, sales people, marketing people, operations people, and so forth to come in. Supply chain management is becoming a bigger and bigger piece of the business. And so here we think that this is really, I think, a huge opportunity for folks that have some technical skills, but maybe you're not totally inclined to go the full engineering route. But there's plenty of other really good paying jobs here where the growth prospects, again, are equally attractive. And then finally, back down to the vocational level, where we have new types of jobs that are being born inside the industry. Things like network installation specialist, network technician, field solar specialist, that simply didn't exist before this technological change took over the business. And so it's an open field, and it's a great opportunity if you want to jump in. So what do the employers say? Why are these jobs so hard to fill? What's not surprising to us, this is the whole foundation of why we put the program together, is lack of experience, training, and technical knowledge. So with so many new people coming in, folks don't have the domain experience for energy, much less distributed energy. And so that gap needs to be filled in order for a worker to get through a successful interview. Number two factor, small applicant pool. This should be music to the ears of someone seeking a job. Whoever heard of this, we couldn't find the right people because the applicant pool was too small. But in fact, this is the dynamic that we find in the distributed energy field. Number 3, lack of industry-specific knowledge and skills. And interestingly, lack of industry-specific interest. Now, distributed energy is a new business. It's a new field. It's probably only been around in any sort of volume for about a decade now, starting with the big boom that we saw in Europe. And so people just didn't know about it. So I guess it's not too surprising that the interest would be low because awareness would be low. That's all changing now. And these are all of the types of voids in the marketplace that the Cyberguardians seeks to fill again, to provide you with the training, the technical knowledge, to bring more applicants into the pool, and to help you develop that industry-specific knowledge. All you need to do is bring that interest to bear. One other point that I would like to highlight here is, and I think this works really well and favors the veteran population, is that right there in the middle of the page, insufficient non-technical skills like work ethic, the ability to show up on time, and so forth. When I've been in conferences discussing what the solar industry is looking for, punctuality, attention to detail, the ability to operate autonomously seem to come right to the top of the list. And this is, I've heard this more referenced in the case of the installation and construction jobs, but I think it pervades the entire field. So here's something that will give a veteran population a competitive advantage, because through your military training, you've learned how to stick to the mission and get it done. And that's very important for employers in this field. Finally, again, the location. And then we'll move on to the next topic. But location often is a stumbling block for hiring managers, because there's a job in Iowa, but the applicant needs to come from North Carolina. Well, this sort of a systemic problem is being fixed with the fact that distributed energy is becoming pervasive. So I think if we do this survey again, location will be less of an issue, because we'll have qualified workers that are available in the states and locales that are required. So why do we need Cyberguardians? And what is Cyberguardians all about? Well, you just heard it. The DER industry needs workers. And these workers come in all shapes, sizes, and skill levels. And they need to be energy and computing literate. So that's one thing that Cyberguardians brings to the table. So literacy. You'll hear us harp on this literacy point. When the founders of the SunSpec Alliance entered the sector, because we came in through the computing and networking field, this is one of the biggest challenges that we have, just understanding the language of the energy industry and becoming literate there was a huge challenge for us. It was a huge challenge for everybody, because there was even a smaller pool 11 years ago than there is now. So we made this a point to build up our own literacy, and we thought, well, we really need a way to fix this on a systemic basis. So we decided to build a course on it. Third point about Cyberguardians and the connection with veterans is cybersecurity. It's complex and it's critical to our national infrastructure and our national economy. And with data communication comes the need for security. So this is a very important combination that means if we get military veterans with the right skills, with the right mindset, we can build a safe, resilient, and a growing and robust economy, all based upon distributed energy. So veterans and your families are great fits. And so we have something for all of you, and anyone can apply for the Cyberguardians programs. We certainly cater to veterans, but we welcome people from all walks of life to enter into the mix. So the concept that was funded by the U.S. Department of Energy was to see what we could do to leverage people coming out of the military that can adapt to the needs of the modern distributed grid, where we have software, we have data, we have communication, cybersecurity is sort of the driving issues. However, to harness all that talent, we needed to have a good system and a concept for educating folks. So we partnered with NABCEP, National Association of Board Certified Electrical Practitioners. So this is the gold standard for vocational training and skills. And so they work with us to vet the curriculum that we produce and align that to the tracks for employment that they've identified have been needed. We have a software developer, T2 Systems, that is one of the main communication software developers in the world here, working on these types of standards. We partnered initially with UC San Diego. They have been our home base for prototyping all of our online education, and the courses that you're about to learn about are all offered through that institution. We recently added North Carolina State University to the mix, so now we're happy to say that we're bicoastal, and we're going to be expanding to cover other regions as well. But the point is that there's certainly diverse needs from an energy mix perspective, and of course diverse populations of people that can now take advantage of some local resources to get trained for these jobs. The bottom line is we're looking for a trained job force that provides a path to employment for your military service and a more secure grid. So that's pretty complex, but we boiled it down. Join the Cyber Guardians, get trained, and get a job. That's what it's all about. Our guiding principle is jobs in all parts of the country are good. We want them to be in distributed energy, so we'll expand that to say that there's plenty of jobs outside the country as well. That's where your interest lies. You know, first step is get a job in your local community. Technical and professional education is really sort of a founding tenet of the program. We believe that there's timely information is needed for all this new technology for all of different disciplines, including down to the vocational disciplines. On the technical and professional track, we have built our curriculum so it meets the core academic requirements for degree programs. So if you are the type of person that is academically inclined, maybe you already have your first degree, you're working on a second one, or maybe you're just getting on the college track, what the information and the courses we provide to you can help you on that journey. On the vocational front, we want to address skills that are in the highest demand right now. How do we know what's in highest demand right now? Well, we look at the NABCEP job task analyses for all the different jobs that exist within that field, and then align the skills that we're imparting to what's required for those jobs. So it's very much about a jobs focus. On terms of the student focus, military veterans first, absolutely. Continuing education for those in the industry is also required, because at the end of the day, this is about filling a knowledge gap, and this means all hands on deck. We have a bunch of great curriculum for you that's available right now for you to enroll in, and we will, over the course of the 3-year period of time, be producing at least this number of courses. We have 5 courses, actually. There's one I haven't listed here, but over 3 years period of time, we'll be producing out or building out a complete program to cover all the different aspects. We started with the fundamentals, and so if you're considering joining this program, I would recommend that you start with Introduction to Distributed Energy Resources in the Electric Grid. And that is a foundational course, and irrespective of where you ultimately land on the job spectrum, that is one that's going to provide you with the basics to understand how does the energy business work, how does the electrical grid work, what are those terms of art, and where do you go to get more information. So absolutely a foundational course. If you are on an engineering or communication track, another foundational course in that field is Introduction to Cybersecurity or Smart Energy. If you have prior familiarity with cybersecurity principles, a lot of this will be very familiar, but then applied to the distributed energy context. So where we're looking at correlation of electrical behavior with communication behavior and seeing what risks and threats are exposed therein. Now, if you're involved in more of the operations side or in the vocational side, I can recommend data communication solutions for PV module rapid shutdown requirements. This is coming up in the October timeframe. This addresses a change to the safety code for National Electric Safety Code and results in a smart system where every panel is communicating. Again, this is appropriate for really any discipline. It does confer full academic credit. I highlight the need more in the business, professional, operational, because it's a requirement that is hitting the country right now and has big implications for supply chain. So important information there. And then in the lower right-hand side, this again is for more of the technical professional and the operational track, the system cybersecurity for IEEE 2030.5 networks. So this looks very specifically at the build out of distributed energy resource systems coming on first in California at the rate of about 250,000 per year being added to this 2030.5 network, and looking at what that means for the operation of the California grid, which will then serve as a template for the rest of the country, as this 2030.5 standard is one of the national standards that has been implemented to come in this year. So that's what we have now. There will be more coming, and as you engage with us, you can learn all about these different career tracks and find something that fits your needs. So how does the program work overall? And then I'm coming to a conclusion here. Well, it starts with a curriculum, and it ends up in credit, either academic credit or vocational credit that's conferred by the institutions you see there. A vocation, NABCEP on academic, NC State, UC San Diego. Most of the information that we provide is delivered online. It can be adapted to hybrid into in the classroom courses as well, but it was designed even pre-COVID to be online. And then it's provided to and through vocational training centers, of which North Carolina State's Clean Energy Center is a great example of that may have their own instructors and mentors that allow even greater learning experience in terms of hand-on application. Community college will be another important aspect of our program. Right now, we are most developed, obviously, in the university and the vocational training centers, and we'll be adding community college support. The idea of the local community college support is to provide that hands-on experience and to provide local mentoring so that you can talk through the issues as you learn hands-on as well as online. A unique resource that we bring to bear for those that are interested in the cybersecurity work is the SunSpec Sandia Cybersecurity Working Group. This is an initiative that we started about 3 years ago. It has published rather prolifically. Our objective there is to set security standards for the nation. And so it is a very popular group within the Alliance. We have about 350 fairly regular contributors. Many of these people are folks that are in the industry, that are working in these types of jobs. And as students get involved here in this track, as they participate, they can learn about their peers and meet them one-on-one, providing even greater opportunity to get in and get one of these jobs. So to get a job and to enroll in the program, we ask you to make that direct connection with employers by going to the Cyberguardians job portal and registering there. We'll talk about that in a bit. This is a growing resource. We'll be adding more jobs every month now. And so, but this is a way that we can vet potential employees. And also mention that even at the outset, if you think you have skills or you don't have skills, you should get registered in this portal. You might just find a fit. And at the end of the day, if you want to get a job, you'll have to go through here anyway. So please explore that. This is at jobs.sunspec.org, and we'll have all the links here in just a moment. Our advisory board is built from companies across the nation that are involved in all different aspects of the solar industry, whether it's Doosan Grid Tech, the U.S. operations headquartered in Seattle that's building substation-sited energy storage, STEM, which you'll hear about, that's providing energy storage and renewable energy all over the country and the world. Grid SME, which is a cybersecurity expert. Both those companies happen to be headquartered in California. And then we have UC San Diego, of course, and you know where they're located, in PIES. This is a company that's owned by Sempra Corporation. It's one of the largest renewable energy, or one of the largest energy corporations in the world. They have operations in about 40 or 50 different countries, I want to say, and also a great employer. Suntech Drive out of Colorado, Rectify out of Indianapolis, doing really great stuff with campus microgrids, working on a project with Purdue right now. Solar Design Studio out of Kansas City, Missouri, operating across the country. Solis Inverters out of Ohio, one of the leading brands of inverters for the entire world, and on the leaderboards of the United States as well. EnerSys, about a $3 billion company, primarily known for all things having to do with batteries. They have lots of different companies, including the advisory board we have works for one of their subsidiaries called Outback Power up in Washington. EnerSys is, though, headquartered in Pennsylvania. And then we have Enter Solar, which is a New York, New Jersey business, and they are, as they say, they're making solar for business. They're an EPC, engineering, procurement, and construction company. And then SMA, another inverter company based in Germany with operation and maintenance headquarters in New York, and SMA America headquarters back in California. So my point in mentioning all this is that we have an engaged advisory board. They're telling us that they need workers, and they're where you live. We have full scholarships for qualifying veterans. So what that means that if any of what you've seen interests you, if you want to learn about distributed energy and take the introductory course, you can do that at no cost to you. You do have to do a few things. You have to apply, and you have to provide to us or your military occupational specialty training information, so we have some idea of what you know already. You need to enroll in the Cyberguardians Career Center, which you just saw, and there's a link there. And then, having done those two things, we'll have a phone interview with you where you should be prepared to describe why you're interested in distributed energy industry, what's your mission here, what specialties are of interest to you. And if you don't know, that's fine. You can list multiple. Part of this is a learning discovery experience on its own. And then finally, you need to declare whether you have GI Bill benefits or can have financial assistance from other sources like the Department of Labor. So this is really more informational from our perspective. As the program goes on, it's in the DOE support wanes, so we'll have to have other ways of supporting this, and this is part of the mix. But for those that qualify, you can get to and through the whole program and get yourself into a job at no cost to you, at least for the training part, by virtue of qualifying for the scholarship. Okay, I went entirely too long, but we have 18 minutes left here. And at this point, I would like to introduce and bring on my guest here, David Erhart. He's Vice President of Engineering at STEM. STEM, it can be found at stem.com. They're a very impressive lot. I've known them traditionally for their batteries, but it turns out they're innovating in all different parts of distributed energy. So, David, why don't you say a few words and introduce yourself, please?
Yeah, great to be invited to the program. Super excited about it. Really enjoyed what I've seen. Been involved with SunSpec and Tom and the folks for a few years now, and just continue to be impressed with the growth of and leadership of SunSpec, and really through Tom's efforts and others. and also very excited to be helping veterans and industry professionals. I'll talk about that pretty soon. But one thing I wanted to lead off with here before I get into my bio is don't get too concerned about the jargon. Like in the industry, we've got our own little acronyms and abbreviations and stuff, and there aren't that many, so don't get overwhelmed by them. There's just a handful. You come up to speed pretty quick on it. So my bio is I'm an electrical engineer. Been at it for 30 plus years. A lot of embedded hardware experience, meaning I designed the hardware for embedded controllers, write a lot of the software for it. And been involved with STEM since the inception back in late 2008, founded in 2009. And I've been pretty much the chief architect for the hardware. So in the early days, we designed our own inverters and battery systems and so forth, and that was pretty rough back then compared to what is available now. The industry has matured massively, which is great. I'm also on the board of directors of SunSpec, and I am one of the tech leads on the Modbus working group. This is a low-level communication standard for talking to inverters and meters and batteries and so forth. So it's a technical working group. I'm also on the board of directors of MESA, which is a kind of a higher-level communication protocol group, but another industry initiative going on there to sort of harmonize a lot of these distributed energy or DER control systems. So as I mentioned, STEM was founded back in 2009. I'm just going to cover STEM really quickly and then kind of jump into some of the thoughts about the program. We're less than 200 people right now, still hiring. We're a little bit south of San Francisco, close to San Francisco International Airport. And we're also distributed around with offices, development offices and sales offices in Canada, Washington, Seattle, Southern California, a little bit of Australia, and we're expanding to some international countries here pretty soon as well. We have about 700 sites, which if you come from a PV industry or something like that, it seems pretty small. But 700 sites, this means 700 individual commercial and industrial sites that have some sort of an energy storage system. And currently that's sitting over 400 megawatt hours, which is in the industry pretty big. It's growing very rapidly. In California, we have about 80% market share for the behind the meter. This means on the customer's premises, so not sitting at a substation or something like that. And again, growing very fast. What does it really mean? It means that we have years of installation experience. So each one of these 700 sites was a project that had to go through all of the same steps and same regulations and same painful exercises, which we'll talk about here in a minute. We have indoor and we have outdoor. Most of the stuff we're doing nowadays is all outdoor. Stuff you're probably going to be seeing, if it's for commercial and industrial, is going to be outdoor most likely because the safety regulations have changed over the years, and outdoor is the way to go. Main goals there for these systems are twofold. One is to save money for the local customer, reduce their electrical charges through peak shaving and so forth. The other is to provide a dispatchable resource to the utilities. So if you have a geographic area where you've got, say, 100 different sites there, you can offer that as sort of a virtual power plant or one big battery system to the utility. And if it needs, it can ask you to dispatch all of that so that it reduces the load on the local utility. And this has actually been used heavily in California over the last couple of weeks. The local utilities have called on our resources quite a lot due to the heat issues and some of the fire issues. So very interesting that it's really ramped up from some of the earlier days. And we're talking hundreds of megawatts now, and it's growing. Within 5 years, you're going to be hearing the term gigawatt hour pretty commonly, which is fantastic. Early days, it was pretty much indoor, at least for STEM, and California, Hawaii, and other places like that. Smaller systems, less than 100 kilowatt. Now everything is pretty much outdoor, and a small system for us is 250 kilowatts, usually about 2 to 4 hours worth of batteries behind that. And sites that we're doing now are starting to get larger, and they're starting just double-digit megawatts with 20 to 30 megawatt hours. So these are big beasts. These are a whole collection of 8-foot tall refrigerator boxes looking things, or they're 20-foot containers, 40-foot containers, and they have to sit on pads that are poured. So there's a lot of work lot of details going on in there. We do sales through partners primarily. We have our own sales organization, but we found over the years that going with large partner operations that are either into real estate or other areas, they have a very large reach in geographic areas, and so that works well. Now, how they get gear purchased and installed is using these EPCs, these engineering, procurement, construction firms, and that is generally where folks like yourselves would end up working with these guys. They would be either hiring you or contracting with you to handle all of the electrical and some of the civil and so forth work. So STEM would see you as part of the part of the partner program. So we would still work with you, but you would be employed over there with the partner. Some would be employed by STEM. We still have to have some touch points where we have some folks working for us internally. We have a bunch of those, but we need a force multiplier for this. So if we want to have installations all over the U.S. and Canada and other places, we have to work with the partners. But each one of those partners really requires an internal touch point. So we still continue to staff up with our electrical folks. So it's a really good way of growing. We have in the past, we've hired industry professionals, meaning folks that have been working in the utility industry, and they have been anything from people that have installed smart meters to actual hardware installation and so forth. And we also have hired a fair number of veterans, so folks from Navy, Marines, Coast Guard, I think Army, and those have worked out extremely well. I mean, one of our longest standing employees I brought in, and he's ex-Navy, and he has done a tremendous amount of the hardware development, and so that's very near and dear to me because my grandfather and father were in the military and so forth. So really liking that. Moving on to, as mentioned in the webinar material. So Tom touched on it, and it's absolutely true. There's a shortage of qualified workers, a real shortage of qualified workers. Solar's been around for over 30 years. Energy storage, as we mentioned, practically less than 10 years. And the real growth in it has been in the last 4 to 5 years, where it's really starting to hit the hockey stick. And a lot of additional companies are offering these energy storage systems. Same items in there that I mentioned previously, a lot of peak shaving and demand response. That's the virtual power plant. But there are increasingly sophisticated programs being offered in New York and California where there's a lot of software controls and a lot of communications involved in that. So this is where getting this education into how to configure these devices and manage them is certainly very important. One of the reasons for doing this as well with the energy storage systems is utilities and the independent system operators, another acronym, can do a lot of capital deferment. If you are going to put in a new gas peaker plant, you're talking a lot of money. But if you can put in a bunch of energy storage and have an incentive program, you can actually defer that potentially $1 billion expense. You can defer it 10 years or 15 years or longer. So we're seeing a lot of that. So that just drives a lot of the sales for us as well. Some of the other things, in California specifically, we've had a lot of fires, and there's been a big push to offer essentially microgrid type capabilities for some of the commercial and industrial areas. So that's driving a lot of business as well. It's basically putting a battery in there that will let them run it for a number of hours. Not quite a UPS, but lets them maintain operation when the utility does manual shutoffs for potentially days. Again, this is all kind of under the shortage of qualified workers banner here. A lot of these things are happening, and the markets are increasing rapidly, and we're not able to find people that can get it installed fast enough. So our backlog continues to build versus us being able to get it installed. What does a shortage of trained and certified workers impact? So if you look at the progression, you essentially start out with usually a site walk. So we'll send somebody out there and actually physically walk the site and say, hey, does it make sense to put some of this stuff in here? Where can you put it? These are fairly large units. And then we get into reviewing schematics and so forth. And then there's a site commissioning process where you're working with the local authorities there. And there's an overall timing of the project. So from inception to operation, and these things are really critical that if they're not done properly, then then you start to back up your project. You're not able to get it done. And that comes from not really being trained, not being certified, and sort of learning on the job as opposed to coming in and saying, hey, I know how this goes, and I understand the equipment. So just watching time, I'm going to move a little fast here. A couple of examples. Recently, we had an EPC that great on PV, really good electrical guy and stuff. He didn't really want to get help, and he decided to install this battery system on his own. And he ended up making some civil mistakes and some electrical mistakes, and in the end, it cost the project probably about 6 weeks. And any money the EPC was going to capture from that, they pretty much lost because they had to redo the whole project. And it's really all due to the electrician, who, again, great guy, super smart. If you're putting in a PV system, I'd recommend him. He was sort of learning on the job, and he made kind of rookie mistakes. So that's one of the things we need. Now, I had a personal experience where my home installation of a battery system and a PV system, it took them 3 days to install the simple battery system. They did the whole PV roof in about 2.5 hours. So whatever money they were expecting to make, they pretty much lost on that. Again, training. They didn't understand anything about the ESS. Tom touched on where the jobs, and I concur, definitely a lot. California, New York, Hawaii still has a fair amount. Ontario has got a lot, but California has got quite a lot because it's a fairly large state there. It is large, and the pipeline for projects, as I mentioned, is growing. And what does that mean, pipeline for projects? It just means that business that has been booked that is waiting to be installed, and it is growing much, much faster than we are able to schedule EPCs to go out there and get it. One positive note, COVID-19 has not really had a big impact on STEM's operations. It has slowed down a few site visits and so forth, but overall it's been pretty good. So let me move on to what I would think the program's important. And again, I'll watch the time and see if I can go quickly here. If you look at the DER installations, right, the distributed energy resource installations, they're happening faster and faster now, just like PV. We hit a hockey stick. And the lack of the skilled resources is just essentially slowing the growth, because if you try to schedule something and there's nobody there, you just push the project out. And so we're seeing this kind of snowplow effect where projects are getting pushed out. And that costs everybody money. So we need formal training, not the cut over from one career to another without real solid training and trying to do self-training. There's just too much moving parts right now. So the UCSD extension and the NABCEP, fantastic. Like Tom said, you got gold standard there, so that's really good. Safety oriented. The voltages on these devices is increasing quite rapidly. People are still trying to push the bounds on what they can get out of it. So getting a really solid background on safety, arc flash, and all kinds of things like this, and particularly around battery. These are not PV panels you drop in and it potentially cracks the glass. If you drop a battery, and there have been recent events like this, you drop a battery, it could manifest as a problem weeks or months later, and these could result in fires. So there's handling that has to really be looked at, and it's just proper training. Once you've got that, you're good to go. Integrated systems, we're seeing, as Tom mentioned, we're seeing much more of the integrated systems. So you're seeing PV and wind and cogens, microgrids, and different ways of connecting PV and battery systems, either AC coupled or DC coupled, and we can go into that later. Another major item here is full service. So some of these things are going in with warranties of 10 years, 20 years. We've even seen some of the utilities asking for 30-year warranties. This industry doesn't understand what that means because the industry is only 10 years old. And so this is not like putting in a transformer and then 30 years later, there's a whole new generation and they understand how to deal with transformer. This technology is moving fast, and just trying to figure out the communication protocol for something 20 years old is going to be challenging. So that's going to be an interesting challenge for people coming into this area. Equipment is aging. We have taken over some existing portfolios of equipment from other companies as they have moved out of the business, and the companies that supplied their gear are no longer in business. So those are some additional challenges. So there's continued learning going on that needs to occur so that these items can be supported over periods of time. So it's not all just cutting edge new stuff. There's also sort of looking back. Now, probably the biggest item in here is one thing that Tom touched on as well, is the whole smart grid. The the grid has changed from this simple wire and transformer, excuse me, grid into this really computer operated now. And that means computer operated all the way from the physical inverter device and battery device all the way up to some panel sitting in some guy's office at a utility hundreds or thousands of miles away. And that is not slowing down. That is increasing more and more and more. And with that is the opportunity for any kind of breaches of security. So very important courses here that Tom has mentioned.
Yeah, thank you for that. So we are actually at the top of the hour, so we're going to go a couple minutes over here. And of course, I think you've addressed pretty much every question that I wanted to ask you. Now, I'm sure some folks on the line here are wondering, okay, well, how do I have a personal conversation with David Erhart? And I think the probably the main way to do that is go through the training and get qualified, and come back and tell David a story about how you can address the pain points that he's seeing at STEM. I would offer that what he's describing here is a story that's repeated across the country and across the industry. So, David, I really appreciate you spending time with us today, and I want to make a few remarks. Great. I want to make a few remarks to wrap up here. First, if you have additional questions, get them in the chat box. We probably won't address them here, but we'll follow up with you in writing. One of the questions that came in is this program for veterans only? And the answer is no. It's for anybody with the interest and the aptitude to get your way through it. So there's plenty of opportunity here. One of the opportunities that I would like to announce today is that not only can you get a full scholarship, but you can also get a SunSpec internship. Now, we have needs that are pretty specific because we are building out these data communication systems and building interfaces and building cybersecurity practices. So that's going to be our interest, is to get folks that are interested in the technical track. However, this is an 8-week program that we're running, and we require that you of course, go through the education. I would recommend starting with the DER Basics course. That was another question that came up in the chat box, is can I recommend another course? Well, the basic DER course is always a good one to start. If you're interested in networking, cybersecurity, installation, etc., it just gives you a really great feel for what the market looks like in a visual format. But the SunSpec internship, again, you have to do all the same basic stuff. Sign up at cyberguardians.sunspec.org, get onto the Career Center, and go through that interview with us. And we're going to be running a 8-week program. We'll have a cohort of between 4 to 8 people in each cohort. And this will give you an opportunity to learn what we're about, to get introduced to the Alliance and our 120 member companies, each one of which could potentially hire you, and including SunSpec, and allow you to get more information up front and personal basis. So with that, I encourage you to go to cyberguardians.sunspec.org, get trained, get a job. Well, we look forward to working with you. Thank you.
Thanks, Tom. Great job.
Okay. Thank you. Bye for now.